First off, we're going to talk about the schedule this week. Today is scheduled. Don't blow that up again, okay? Today is scheduled as our only math day this week, with tomorrow and Wednesday being build days. Tomorrow and Wednesday are going to be build days. Stop. Because it's dry, and we have to finish the floors. So we're going to put insulation in the floors and then some sort of floor, plywood. And that has to be done when it's dry and we can't have rain in the floor. So the next 2 days are going to be really crucial build days. So I'm just going to preface already that when we're out there, you need to be working. Okay. Also, I'm going to preface with if we don't get the math done, then we'll just wait for some other nice days. Because, you know, we agree that the math comes first. Okay? So I'm only saying that because for some reason third period was in a bit of a mood today. And so we have a certain amount to get through, and they might not get a build 2 days, and you guys will if we get through the math. Yeah?
So the homework was all, there is homework that was due today, right?
Yes.
Okay.
The homework that was due on Friday that 8 of you did not turn in, 8 of you will not be building tomorrow. And then the homework due today will determine who builds on Wednesday. So however many of you do homework today, if you don't have it turned in, you won't build Wednesday. Yes, sir?
I was just wondering the homework numbers for tonight. I can't do that.
34 to 38, 42, 45.
3.
43.
Okay.
Yep. So I was going to put that up as well. We wrote it. Yeah, it was originally written down for last Friday. We're changing that because we added in that Faja board.
Fascia.
Johnny, it's your face.
Fascia.
Yes, yeah, okay. Yes. Yeah, no, yeah. Okay. KG. All right, so I will also point out, do not ask us today if you can go work on Tech Show. Do not ask us tomorrow if you can go work on Tech Show. Do not ask us on Wednesday if you can go work on Tech Show. The only time that I will say yes, you can go work on Tech Show is during 8th period on Thursday.
Oh.
So not during 4th period when we see you the first time on Thursday, but that second 25 minutes, if you want to go work on Tech Show, be my guest. Especially if some of you are gonna come to the build day and you're like, oh, Miss Lindsay, I didn't do my homework. Can I go to Tech Show because I don't get a build anyway? Be like, no, that would only be rewarding your poor choices, which I'm not into. Okay? You could probably open it. You could probably pull it. Maybe. Oh, you're late? There you go, muscles. Whoa.
So funny.
Okay. So questions about the schedule this week?
What do we write for homework on Thursday?
I'll have a homework assignment on Thursday. Want me to give it to you now? Four, 7, 5, 1.
That's a lot of problems.
There you go.
What is that?
I'm sorry?
Who's back there?
What? What are you talking about? I have to give you, I'm just going to try and preface this because I'm trying. I talk to you guys a lot about this type of stuff, about how you learn, what actually happens in your brain when you're learning. So this is like the same way when you learn, whatever you learn, or how you learn new things. Basically what happens is when you're trying to learn a new skill, or a new concept, or whatever new thing for your brain, there are neurons in your brain that create pathways. The first time you learn something, there's not a pathway in your brain. Right? It's your brain's basically trying to play like a connected dot, and it might go out around a little ways and kind of go in a roundabout way. And that's why sometimes when you learn a new thing, it's kind of fuzzy. But then the more you practice that thing, whether it be in math or a skill, or you're trying to learn to ollie or whatever it is you're learning, the more you practice, the more that path, that sequence of neurons firing gets embedded in your brain. And the more times your brain uses that same path, the easier it gets. You can kind of think of it as stop. You can kind of think of it as there's a groove. Your brain starts to create a groove or a path through this certain network of neurons. And the more times you do it, the easier it gets. That's why things start to become second nature. You guys don't drive yet, but one of those things is like you learn the path that you take to work or to school. And there will be times where you drive, and I'm sure this happens to Mr. Fishy sometimes, it happens to me on my bike, where I think like I'm biking, and then all of a sudden I meant to go somewhere else. Like I was like, oh, I was going to go to the store after work, and suddenly I'm at home already because your brain gets on this autopilot thing. It's because you've created such a deep groove or path that your brain just does things automatically. Okay? So, all that to say is when we're learning in here, we're trying to get you to create those networks in your brain. And you do that by engaging in whatever material it is we're talking about. If you don't engage in it, there's no path that's created. Nothing happens. And so then, of course, you don't learn anything. That's the first thing I'm going to tell you about. Is we're trying to create some pathways in your brain. The second thing I'm going to tell you about is that there are different ways to do that. Right? There are different ways for you to learn. Research has shown, and it is my preferred way, that you guys are engaging with the material. Right? You're measuring things, you're observing things, you're outside trying to figure out how to lay out a foundation. I could have just told you how to do a foundation layout, and then we could have done a foundation layout, and yay. Right? I could just tell you all the information that we're going to cover in class today, and then you could apply it in a worksheet of practice problems, and I could sit you all in rows, and we could be done. I think that that is boring, and I also think that's not how you learn best. But if we have to do that, we will do that. Okay? What I'm saying, though, is when I'm going to ask you today, I'm going to ask you to measure, I'm going to ask you to do new problems, I'm going to ask you to do all kinds of stuff, like most days, that you're actively engaging with that stuff. That you're not just taking up space. Okay? So, be attentive today and make the connections. That's what we're saying. So, first one is this. You've seen this before. Or a very similar shape. This is what we did at the end of the day on Friday.
Yeah.
Definition of a rectangle. Sean, what do you got?
190-degree angle, 2 parallel.
490-degree angles. Perfect. That's it. The definition of a rectangle is only 490-degree angles. But like Sean was just getting ready to say, he was getting ready to say some other stuff that's also true about triangles. Parallel sides. You guys, nobody's picky. Quadrilaterals. Quadrilaterals. Okay. Parallel sides. And what else is true on quadrilaterals? For show, for show. What's true about them? Great, they have 4 sides. Let's go a little deeper into something that's useful. Awesome. For a quadrilateral, how do I know if this is a, I'm sorry, did I say quadrilateral? God. Ugh. Okay, rectangle. Back to it. For a rectangle, I know it has 4 90-degree angles, and I know it has parallel sides, and what else? For a rectangle specifically, not a quadrilateral. Kenya? Yeah, use a math word. Congruent, beautiful. The diagonals have to be congruent. And I'll remind you, I'll just show you. Remember last time, you couldn't just use those slanted anti-sides. We need to make a right triangle out of the diagonals. So draw on your diagonals, make a right triangle out of them like we did last time. What?
Also, fact about rectangles is that they're used by many, and actually pretty much all companies that make boxes.
I agree. They're boxes, yes. Ooh. How about your homework, please?
I have something Hey, I know her now. Is that her?
No.
Here's how this is going to work any day. You guys were at 8. 5 of you didn't do this homework assignment, so now you're at 13. It's going to be a running total at the end of the quarter. The class with the least, smallest number wins the pizza party, right? So you guys are soundly in the lead right now.
Wait, what did they
They had 19.
Long time.
They had 19. So 6 of them, they lost by the day as well. 5 of you didn't do homework and 6 of them didn't do homework. So they lost the daily count and the total is still losing. Okay. All right, let's talk. As a reminder. What?
Wait, so this is a class mark, right?
Uh-huh.
What if somebody in there like did all of their homeworks?
We'll make them breakfast. They get a special. You get a special award for that. That's semester though. Actually, I would be tempted to say if you did all of your homework. No, I can't say it. I'd be tempted to, but I won't. It would be tempting.
Say it. You can't just bring it up. and not
I
say
could.
it.
Well, I don't. Okay, I would be. I'm tempted to say, and this is not a deal. Not a deal. I'd be tempted to say if you did all your homework, I won't make you take the final.
Are you serious?
Yes, I'm serious. Here's the deal, though. Oh, wait. I'm not saying that, though. I'm tempted to just because I think it's that important. Like, if you did, most of you guys last semester who did all your homework, you know, just saying. But some of you sometimes, like, write crazy things on your homework, and I wouldn't be counting that. Like, if I saw crazy on your homework, I'd be like, no, that's crazy. Like, that doesn't count. You just...
Either right or I don't do it.
Huh?
Either right or I don't.
Yeah, but I'm not saying that. I'm tempted to. Maybe. We'll decide. We'll see how bad it gets.
What's up?
Nope. So, although good job doing homework. When we are talking about this rectangle, we are talking about the diagonals. I need you to have your notebook open, Matthew. Let's do one step at a time. I'm trying to figure out the length of that diagonal. Now, yes, if it were a rectangle and we were not on graph paper, you would probably use the sides here. If it were a rectangle, you could just use the sides of the rectangle for your Pythagorean theorem. But since we do not know if it is a rectangle, we A, can't use those sides. But B, we can't use those sides because I don't know even how long that is. I don't know how long that is, and I don't know if those are a 90-degree angle. Right? On graph paper, the whole reason we use it is because the x and the y axis are at a 90-degree angle to each other. So just like we did on Friday, if I want to calculate that length, I'm really looking at this right triangle here. I'm really saying, okay, there's a 4 by 7 triangle. Right? I'm trying to say, okay, great. 4 squared plus 7 squared, 16 plus 49. I don't know. Whatever.
65.
Great, 65. And then I'm comparing that to the other diagonal, to DB.
Which is a 5 by 2
Okay.
triangle.
And again, I need to turn this into a right triangle. So I'm going to go this way. You could go either way. It doesn't matter if you go above or below the line. But I would turn that into a right triangle. And I'd say, great, this one is 5 by 6. And without even, like, let's slow down a little before we start squaring a bunch of stuff. They're different. You have a 5 by 6 and then a 4 by 7. Is that going to be the same length?
No.
No. Like you already know just by doing that. I didn't even have to do Pythagorean theorem. Okay? So the diagonals here are different lengths. They are probably pretty close. Like if you actually end up doing them, they're probably within a few decimal points of each other.
No.
But
There's gonna be someone off. Actually, no. 20 decimal points.
yeah, okay. So they're kind of close, but they're not the same. They're not the same. So therefore, said shape ABCD is not a rectangle.
Say what?
What?
But if you drew the triangle like you drew the first one, then it would be the same. It's the same dimensions on the triangle.
No. If I drew the triangle like the first one, what do you mean?
Like,
Go down here?
yeah, if you went down.
That's still gonna be the same as how I did it.
No. If I go
You
down,
must have drawn it wrong then.
yeah, maybe. If I go down, I would still be, that's 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5. Still 5 by 6. Okay, next question then. What shape is this? Right now, anything you say is a conjecture or a guess. What do you think that is?
Quadrilateral.
Okay, quadrilateral, a little more specific. Do parallelogram. Now, no, I don't know what I did. It's a parallelogram if what? If they have two pairs of parallel sides. Okay, so let's break it down a little further. How do I know if those sides are parallel? You want to run it by your team first?
They're both nice.
I don't know that those are parallel yet. I'll say they look parallel.
Almost 90 grand.
I had an error.
How do I know if, what, you got it? Okay, nope. I mean, that's a good start. They have to be at least opposite from each other. So, when I'm looking at this AB, how do I know if this, I'll give you a hint, if this line AB, how do I know if it's parallel to line DC? Say it again.
If they have the same slope.
You know? It's like, yeah. Hold on, no, there's not. Mathematically, these are parallel if and only if. The only way I can guarantee these are parallel is if they have the same slope. Okay? So,
There is a way to figure that out, Reed.
hold on. What I want you to do right now, from A to B, we know slope is rise over run. I want you to write down what you think the slope of AB is right now. Write it down. You have 15 seconds. Even if you're wrong, write something. A to B. What's the slope between those 2 points from A to B? There's a lot of lines, I know. From A to B, what's the slope? No. Josephine.
5 negative.
No. I'll just give you a hint right now. Eli said 5-1, Josephine said 5 negative 1. What is slope defined as? One more time.
Rise over run.
You know how you said that word over in the middle? It's a fraction. Rise over run. So let's try with that. Mitchell, what? 1 over 5. No. Major. 1 over 4. No. Maximus.
-1/5?
-1 over 5. Yes. Now, Yes, negative 1 over 5. Because look, from A to B, the rise is down. It goes down 1, and then it goes over 5. Another thing to point out. Some of you might go say, well, but from B to A, it goes up 1 over 5. Could a line have can a line go up and go down? This line?
But you read from right too, or left to right.
Okay, again. Hey, look, Max. I understand in your brain, like I understand the thinking of like, well, if I go from B to A, sure, it's 1 to 5. But you don't go from B to A. Because you read graphs the same way we read words from left to right. Also, when I'm looking at these actual numbers, I'm saying as these numbers, as x increases, y is decreasing. Okay? So, the slope here is negative 1 over 5. Negative 1 over 5. What?
The only reason that would ever be 1 over 5 is if you're reading it in Chinese.
Okay, yes. Maybe. I'm not entirely sure, but I think Chinese is up and down.
Happy Chinese New Year.
Yes, but it's also right to left.
Yesterday, right?
Thank you.
Okay, Mom, up and down, and you read. Nice. Hey! So hold on. What about the slope from this D to C? Hey, is D to C negative 1 over 5?
Yeah.
Yeah?
Yeah.
Okay, so check it out.
From D to C?
Yeah.
Oh, yeah, it's like 5, yeah.
So look. Hey, Major, hey. The slope here is negative 1 over 5. The slope here is negative 1 over 5. Can we now say that this is a parallelogram?
Yes.
No.
Wait.
What's the theme of the semester? Proof. Do you know for sure, without beyond a shadow of a doubt, that this is a parallelogram?
No. Yes.
No, you don't.
You don't know the other two.
Because I need to know that side, and I need to know that side. Write down the slope for that. Can you see what I'm pointing to? There we go. That and that. That was good. Write down those two slopes. Write down the slope for AD and the slope for BC. However obvious you might feel that exercise is. Write down the slope for AD and the slope for BC. Hey! Taylor, go ahead. Look. Hey, mira.
That's good, yeah.
The slope here is 6 over 1. The slope here is what? 6 over 1. Now, and only now, can we say, for show, that this is a parallelogram because opposite sides are parallel. Okay? So when we're talking about proof, I'm just trying to get this running in your brain. Yeah, that's super redundant. And yeah, I have to be that specific.
It's a long one.
Also because I'll tell you, like generally, if the theme is proof, with proof comes argument. And some of you, maybe some of you are terrible arguers, but also maybe you have experience arguing with someone who says, I'm right because I think so, or other dumb, vague arguments that aren't actually real. So we're going to be talking about things like that are proof-based, that are fact-based, that are things that we can measure, things we can observe, and qualify. Just so we're clear. Okay. Next, speaking of proof. Oh, your homework. You guys, it's really quick. 3 minutes is okay?
Yeah.
Maybe.
Before you get started, and what I'm going to draw your attention to is 27C. On 27C, if your table comes up with the answer of 12 milliliters, please reevaluate because you're incredibly wrong. I say that with love. The answer on 27C is not 12. And this is like, you may want to look back into your notes, something. I'm not saying. But take 3 minutes to discuss homework. Please focus. 3-minute conversation. Ready, set, go. Everybody. I'll show you tomorrow with a hammer. Just kidding, I won't. Okay, we have some serious discussion to be had about 27C. Mostly because this is a problem on your group quiz that majority of tables missed. Now, if majority of tables missed, that makes me even more scared because that means probably at like the 2 to 3 tables who got it right, it might not have even been most of you at that table who knew. So, I'm going to not talk about the tree problem specifically, as I'm going to talk about a general scale problem that we can then expand to the tree problem. So, let's just suppose, please be quiet. Hey! Stop. Here's the deal. Honestly, you won't be able to say bless you if you're going to be ridiculous about it. The whole like funny, like we're going to say bless you really crazy thing, I don't find funny. So chill. Okay? Let's suppose we have something. It's not a tree, obviously.
I can't.
But it's 1 inch by 3 inch. Major, was that you? Do you think that's funny after I just said that? Shh. Just don't say anything. Also hold in your sneezes. No, you don't need to say that loud. Also, the person right next to someone, that's the only, how about that? It's the only person who may say, bless you. If you're sitting next to someone and they sneeze, you can say it. If you're sitting diagonal across the room and Eli sneezes, I'm like, bless you, Eli! I said it loud. Like, don't irritate me, okay? Great. What's the area of this rectangle? Area. 3 square inches. Great, fantastic. We are going to multiply each side of this rectangle by a scale factor of 6. So, new rectangle, scale factor of 6.
I like your confidence.
Shh. Multiply them by 6. I went like this. What's the new length here? 6. Don't get crazy. Over here, what do I have? 18. Great. What's the new area?
108.
Huh?
108.
108. How many times bigger is the new area?
36.
36. Wait, what? It's not 6 times bigger? No, it's not 6 times bigger. Okay? How do I go from 6 to 36? Squared. Why does it make sense that it's square, Mickey?
Because you are multiplying the area of it rather than
Okay.
the surface area rather than it's a square measurement.
It's a square measurement. That's one way to think about it, right? We said our one-dimensional, right? My one-dimensional scale from 1 to 6, just taking that as one, side, I guess. 1 to 6, 6 times bigger. Now when I'm talking two-dimensional, it's squared, right? This number is squared. Square it. You have to square your scale factor. We've been talking about this for a long time, right? A one-dimensional measurement, when I look at a square measurement, right, my factor is going to be squared. Let's suppose I have a side ratio is 6. An area ratio is 6 squared. What's my volume ratio going to be? I'm going to say that one more time and more of you are going to raise your hand. My side ratio is 6. My area ratio, a square measurement, is 6 squared. My volume ratio, a cubic measurement, is what? Chris? 6 cubed. Right? Mostly because math makes sense. Because that should be how it is. Okay? So, this is like the last time I want to have this conversation. We've been talking about this for a really long time, and this is a big idea that I need you guys to hold on to. In the very least, here's what I would hope would happen in your brain. What happened in your brain is you would be doing your homework, and you would do 27, and you would go, oh, it can't be really as easy as just doing 6 times 2, or 2 times 6. It can't be really like, oh, there's something. Miss Taylor says, There's something about sides and area. I don't remember what it is. Even if you didn't remember what it was, here's what I would do. Maybe you don't remember. So maybe you do a little problem for yourself where you're like, oh, okay, let's just pretend I had a 3 by 2 and that area is 6. And if I triple each side, right, if I multiply each side by 3, my new area is 54. Oh yeah, if I multiply my sides by 3, my area is multiplied by 9 because 3 squared is 9. Like you could build that. You could go back and figure out how the area ratio relates to the side ratio. That would be fine. What you have to know they're different. If I scale the sides, I end up squaring that for the area, right? If I scale the sides, I would cube that for the volume. Yes?
Yes.
Okay. It's on your group quiz Friday. Lots of you missed it. We need to stop missing it. We need to learn. We need to create those brain ruts. Okay. Other than that, I want to talk about 29B just because you've probably seen it before, but a little rusty, so let's move some of that rust. On 29B, I know you can maybe see, if this were a square, the diagonals bisect each other. Since the diagonals bisect each other, what does that mean about this length and that length? They should be the same, they should be congruent. So I have to write a new equation, that's what I have written on the board, where I would write out that these two lengths should be the same. Ugh, right?
Plus 5 equals.
Yeah, this and this should be the same. So I write an equation that says x plus 5 equals 3x minus 9. And all of us have done this before. Whether or not you feel like you're very good at it, I'm sure you've seen it before. Okay? So you're going to start this semester, I'm just warning you. We're going to be, last semester, some of you caught on that we skipped a lot of the algebra stuff. This semester, we're not going to be skipping it as much. Because we're going to slowly start practicing to make sure we have some of those skills. Okay? So you'll see more of these types of problems. If you need help because you kind of forget the weird rules or aren't really sure what's happening, I'm happy to help you. Okay? But the answer would be 7. The answer would be 7, just to point out. Okay? Lastly, on 33, here's what I saw a lot of you write on 33. A lot of you wrote 38.4 on 33 because you wanted me to knock you upside the head, I think.
Yeah, I got it right.
No, if you wrote 38.4, you didn't get it right.
38.
Goodness, if you wrote this, no, don't smoke. Okay. Don't write, were you talking about, right? Like measuring, you can't tell me 38.4 inches. I will look at you like you're crazy.
And smack it for the head.
And it, yeah, lightly. It'll be a love tap. Right on the temple. Okay. Do we know how I got from 0.4 to over here? Awesome, fantastic. What did Google tell you, Ethan? I'm not sure. How do I go from 0.4 to 6/16? That's what I want to know.
Well, first you do it 4 times.
I took that 0.4 times it by 6.4.
Beautiful. Hey,
6.4 was
why do I multiply by 16? Meadow, what? Awesome. Inches are divided down and broken into 16ths. Beautiful. Okay, great. What? Okay. Fair question. Hey, you better listen to my question. Answer. Here's how this really came out. 3.2, I said I'm turning feet into inches. There are 12 inches in a foot, so I multiplied by 12, and I got 38.4 inches. So I multiplied by 12 for inches in a foot, but then I want this into 16ths. So I'll multiply this now by 16ths and say, so it was 38 and 6/16. My last comment is this is probably the only math class you'll ever get away with writing 6/16. Yeah, you should simplify that fraction technically. But if we're outside and you tell me 6/16, I'll take that versus you telling me 0.4. Also because I'm still learning about the measuring tape too, so I'm cool with that. Mrs. Rich, you probably tell him 3/8, but yeah, but it's okay. This is we'll get there. Okay.
So if you were 3/8.
Remember that part of the class where I was telling you about one way you can learn versus another way you can learn? We're now at that portion. Here has everything that you might need, the directions, you need a ruler. The directions on here are all you should need if you read them. I don't know what else I should tell you. You should read down here too, like you should read it. There's not very many words, but you should read the words that are there. You should work in your tables to help each other out. Is this what you're doing? Are you doing the right thing? I'm going to let you guys make sense of this. I will say you need to be done with the front. You need to be done with the front 8 minutes. You get 1 question per group. Use it wisely. Inches long. Where's the middle? 1.5. Right? Again, it's not that this is a complicated task. It's that maybe there's a little bit of laziness or checking out. So
you're taking the measurements of the sides and dividing them.
yeah. So find the middle of 2 of the sides, not all 3. You can find the middle of any 2 sides. Connect those. You've just made a midpoint. Okay. So middle of one side, middle of another side. Connect them. Midpoint. Do that thrice. 3 times. 3 times. The bottom of the paper, I ask you to, hey, measure the mid-segment, measure the base. The base would be that 3rd side that you didn't connect the mid-segment to. The base and the mid-segment are parallel. Whichever one is your base. Like, I don't care which one it is. Okay? So, that's what you're trying to do, right? So, measuring, being accurate.
It's like what we did on our homework, right?
Hey, you could have drawn your line. Some of you might have drawn your line this way. That's fine. You might have drawn a line there. Or you might have drawn a line the other way. Also fine. Do not draw all 3. 1. You may have 1 mid-segment drawn.
What if I drew up 3 before you said not to? We got a rebel.
Hey, shh. What if we didn't interrupt me? Duke, no. Okay, so the big thing, the whole reason we're doing this, and I guess I don't even have to say, you don't even necessarily have to write down the measurements of the side lengths, like if that's just going to confuse you. You just need to mark the middle of each side. So some of you went like this. Some of you, for this triangle, you have this. Why is that not okay? Because it's not in the middle. You just drew a line willy-nilly. Some of you have lines that you didn't even use a ruler for. You just are drawing stuff. And again, here's where the issue is. The issue is not that you don't know how to use a ruler. The issue would be that if you don't know, ask, or don't be lazy. Because the same thing happens when we go out and build. And while this frustrates me here, I never knew it frustrates me endlessly more outside. Like I go outside and we go, hey, cut this at 68 3/4 inches. You got it? You're like, yeah, I got it. Yeah, no, I got it. And then you come back with a board that's 64 inches. And I'm like, what happened? If you don't know, ask. Right? That's why we want to measure twice, cut once. Don't work by yourself, because then you make even more mistakes, and working with someone else, don't just do random stuff. Like this is you just going, nah, I don't know, just put this crap on here. Right? Don't be lazy. Okay? I'm gonna cut you off though because you're taking too long. In your notebooks, we need to write some stuff down.
Yeah.
So, get out your notebooks. We're talking about G5. Yeah. Okay. Hey! Not an invitation to chitty chat. Mid-segment theorem.
Looks like it's leaking, bro.
This is leaking.
Turn it around so it's just on the floor. Instead of punctuating.
It's not leaking from there.
From the knob. Yeah.
Oh, I thought you had to leave.
All right. We are going to talk today about the mid-segment theorem. By hand. What is a theorem? What is a theorem, Finch?
Kind of just like it's a theory that you have the information on, but you just don't know if it's correct or not.
Okay. That's one. Okay. You don't know if it's correct or not. Is that true? Think. What's a theorem that we know? Pythagorean theorem. Is that wishy-washy? Right? The Pythagorean theorem. Remember we saw that that guy who was talking about theorems?
Honeycomb theorem.
And that the thing about theorems is not that you don't know if they're true. You're talking about a theory, maybe, but it's you know it's for sure true. So it is true. They are true. What else we got? Chris, how do you think?
It's like an idea back behind like facts.
Okay, an idea back behind facts. How else could we say that, Sam?
How you do it.
Isn't it mathematically an equation or like fact that is true in all cases for this?
Okay, true in all cases. How do we know it's true?
Prove
This
it?
is a theorem.
Duke?
Well, isn't it more like it's been discovered because we just made it up? Like it's true for everything because it's proven.
Okay, so talking about like a naturally occurring truth. Like this is something that is true for everything, not because we made it up, which is all of mathematics. Okay, what else? Yeah, Nikki.
It's a property in math that we figured out.
Is it only in math? Are theorems only in math?
Nope. Science.
Do you know of any theorems in science? Not theory, theorem.
Well, no, they're all in math. It takes math.
Arden?
to do the theorems in science.
Wait, theorems?
Uh-huh. What do you got about theories? That's fine, because we hear more about theories.
Well, theorems. There's a step between what some guy in the middle of math class just thought up and what some guy went out of his way to prove in every single way possible that it is true.
Okay. I'm gonna Google it.
Wait, can I put in my guess?
Yeah, go ahead.
That's what I was gonna do, but I got enough phones to call.
What?
Is it a proven theory?
Between.
Because you have this weird back there, what's that proving you have?
Yeah. So there is a difference. I'm just making sure, right? And the big difference, theories explain why something is true. Okay, this is what it says.
Theorems explain
A
how.
theory is used to explain why something is true, or to be or as a set of rules to say this is always happening. Theories can be observed, right? Give me a theory that's observed. Zanaya, you know any theories? what's this theory?
Gravity, bro.
Every time. Every time.
Gravity.
Every
Oh,
time.
What if
Right?
sometime you dropped it?
Hold on.
Global warming.
Hold on. Listen, please. The theory of gravity explains why no matter what, every single time you drop something, it falls to the ground. That has been true always.
It also explains.
Okay?
why
Hold on.
everyone
Shh.
thinks-
I'm not asking for input right now. I'm also not asking for side conversation. A theorem, different than a theory, has been proven true. Okay? Yes. Has been proven true. So, like, some people like to make weird arguments about science and theories. Guess what? I'm not going into that. Because a theorem has been proven true. You can't, like, we're going to talk about the mid-segment theorem. And it's not like, it's like the Pythagorean theorem. Like, that's always true. Infinitely true. Okay? So, the mid-segment theorem is basically this. Based off observations of looking at a triangle's base as compared to its mid-segment, what do we notice? Mickey's the only one who noticed something? Stevie, what'd you get? Anything back there? Josephine, you should sit right next to you. We got two people, you don't got nothing? Ask them. Cecilia? Huh? You gotta be more specific. It's divided. What? What's divided? What are we talking about? Two's divided? You're not making sense right now. So use some math words. What's it? What's divided? What's from the base? No, don't say never mind because I'm pushing you. Don't say similar triangles. Shayla, help her out. Shh. The base is getting divided by 2. To get what? The mid-segment. Okay? This is only true. Notice, did anyone do the back yet? No. It's not true for trapezoids. We have to be specific about triangles. The mid-segment theorem states that the mid-segment of a triangle, specific to triangles, is half the base. If we were to draw this out in our notes, so I have some sort of triangle here, those are equal, those are equal. So notice with my notation, even though I drew a wonky-tonk triangle, my notation tells you that those sides are cut in half. What's the math word for cut in half? What?
Bisect.
Bisect, right? So the mid-segment, I could have also said on your paper, I could have said it bisects 2 sides. Kimani? Okay? I could have said the mid-segment bisects 2 sides. So here's the base, here's the mid-segment.
So scared when we woke up.
If I was going to write a formula, I want to write a formula that reflects this sentence. The mid-segment is half the base. The mid-segment is half the base. Major, what do you got for my formula? Mid-segment is half the base. Meadow? Close, but it has to reflect this sentence. The mid-segment, so I should start with mid-segment. Mid-segment is half the base. How do I say that? Someone I haven't heard from today. The rest of y'all, put your hands down. How about this? Check in with your team. Write a formula real quick. 30 seconds, then I can call in any of you. The mid-segment equals half of the base. I'm okay with that. The mid-segment equals half of the base. What? What, Josephine?
B over 2.
But that's what you said. You said the base divided by 2 is the mid-segment. This says the mid-segment is half the base, which is the same as a sentence. You're still right, though. I could also say, I could write this at least 3 other ways. Yeah.
M equals base divided by 2.
Yep, you could have also said and this is close to what Josephine was saying as well, I could also say it like that. It's the same. Whether I multiply by a half, hey, pay attention. Multiply by a half, divide by 2, same. Okay, next. Here's what I need. I'm going to break down the directions right here on the back. I'm going to give you an example. All I want you to do, I only want 3 measurements on your paper. So I want you to make the mid-segment. Okay, I want you to make the mid-segment.
Okay, gosh.
And then I want you to measure just those 3 things. Just those 3 parallel sides. I want one person to do one, a second person to do the second, and a third person to do the third.
I already told you.
That really do that stuff.
Oh, no, you must better go to sleep now.
You should be able to have a mid-segment theorem for a trapezoid. In the very least, this is your exit ticket. Maybe you don't have a theorem, but you have some sort of way of how you can think about the mid-segment when now it's not a triangle, right? It's chopped off from a triangle. So what's the mid-segment? There. That is your exit ticket, meaning it must be done for you to leave at 3:15. Ghost.
I'm out of here.
You will not be able to leave, or I'm not saying once you have it, then you'll leave. You won't leave it early. But I need each of you to turn in one of these on some sort of scratch paper. It needs to be correct. So you might not need to work in your group and come up with either an observation.
Wait, what are we supposed to be? Can we just find the length of the one that we just did?
Nope, this one here.
Damn you. Hey, guys. I was telling you to do.
I got it!
I know. I'm a disappointment. I'm having to help me every day.
You're not a disappointment.
Come on, Dan. Yeah, the desk is even big.
Wait a second.
Way too much.
If these are. Wait. This is just.
No, it's that.
Well, since the base is divided by 2, the base is 6. We can't divide it by 2.
It's not a triangle. Cause like, no, like, cause like, if you had a triangle, I'm figuring it out. You did the middle section, and then you cut off the end of it. Cut off the middle section.
And still having your midpoint. So either way, mid-segment theorem.
Yeah, but if you divide by 2, but how about this? If you divide it by 2, you get 8. It's clearly longer than 10.
4 to 8.
It looks like you can add 2.
See?
I just call it X. Really? No, I think it's 12.
Dude.
I have a. Wait, hold on. Hold on.
Just say that to me.
Wait. Wait, let me. Wait a second, can't you just find.
What?
Never mind.
You can try it early if you want. You can't leave early, but you can try it when you're done. I'll tell you, yeah, you're
What would you be a shooting top?